Good day, everyone. I am Kristal and Coyoca from BEAD 2B, and I am the last reporter, and I will be discussing the functions of scaling and the important things we need to remember when using scale in technical drawing. So, let's start. Function of scaling. So, to measure or lay out line distances accurately, either in full size and larger or smaller than full size. So, to measure or lay out line distances accurately, a scaling helps us measure lines correctly, whether they are the same size, bigger, or smaller than the real object. And the next is uh, to produce drawing to a certain sizes. Um, so to make drawing into a certain size, um, this means we can draw something large or small in a way that still shows the correct proportions. And the next is manageability and representation. Scaling allows designers to fit large objects like buildings or landscapes onto standard paper sizes, example given A4 or A3, or to enlarge small objects like intricate mechanical parts to show fine detail. So, uh, manageability and representation, scaling makes it easier to draw big things like buildings on normal sized paper. And it also helps us enlarge small things so we can see the details clearly. And the next is accuracy and measurement. It ensures that drawings are proportional to the real world object, allowing for precise measurements to be taken directly from drawing using tools like a scale ruler. So, accuracy and measurement, um, when a drawing is scaled, the sizes stays in the correct proportion. We can use a scale ruler to measure directly from the drawing and get the real measurement. And the next is standardization and communication. Using standardized scale ratios, example given 1 to 100, 1 to 50, 2 or 1, creates a universal language among professionals, architects, engineers, builders, reducing errors and miscommunication during project execution. So, standardization and communication is using common scale ratios like 1 to 100 or 1 to 50 helps architects, engineers, and builders understand each other easily. It reduces mistakes because everyone uses the same drawing language. And the next is visual hierarchy and emphasis. Within a composition, variations in scale guide the viewer's eye, create a focal point, and signal the importance of different elements. A larger element typically commands more attention than a smaller one. So, ang visual hierarchy and emphasis is changing the size of objects in a drawing helps show which parts are more important. Bigger elements catch the viewer's attention first. And the next is planning and experimentation. Scaling enables designers to test ideas, compare different design options, and estimate materials cost and quantities before committing to a full-scale physical implementation. So, planning and experimentation, scaling helps designers try out ideas, compare designs, and estimate materials before starting the real project. Then, now we already done with function of scaling. So let's proceed the things to remember. So, whenever possible, the workpiece must be drawn into full size. So, draw in full size when possible. If the object fits on your paper, draw it draw it the same size as the real object. This makes it easier and more accurate. It easier and more accurate. So, uh, next is when dimensioning, always enter the actual dimension of the workpiece. So, when adding dimensions, always write the real measurement, even if the drawing is smaller or bigger. The numbers the numbers you write should always be the actual size of the object. And the next is angular dimensions remain the same regardless of the scale to which an object is drawn. So, angles do not change in scale. If you scale a drawing bigger or smaller, the angles stay the same. Then next is the first figure of a scale designation refers to the dimension used to construct the views. The second figure of a scale designation refers to the actual dimensions of the object being drawn. So, understanding scale like 1 to 2, 2 to 1, etc. The first number tells you the size you draw, and the second number tells you the real size. So, example, 1 to 2, drawing is half the real size, and then 2 to 1 is drawing is twice the real size. So that's the example, and then let's proceed. So next is maintain proportions. Always apply the same scale factor to all dimensions, height, width, depth, to avoid distortion and preserve the integrity of the original design. So keep the same proportion. When you scale something, make sure all sides change by the same amount. If the height becomes twice as big, the width and depth should also become twice as big. This keeps drawing from looking stretched or squished. And the next is use the correct tools and methods. So, employ appropriate tools like a scale ruler, grid systems, or digital software features to ensure accuracy. Avoid freehand scaling for technical drawings where precision is critical. So, use the right tools to get accurate measurements. Use tools like a scale ruler, grids, or digital scaling tools, and avoid it by freehand, because it's easy to make mistakes, especially in technical drawings. And then next is indicate the scale clearly. Always note the scale used on the drawings. Example given, scale 1 to 100, Yahoo A3, to provide a clear reference for anyone interpreting the plans. So, write the scale clearly. Always show the scale you use on your drawing, like 1 to 100 or 1 to 50. This helps other people understand how big or small the drawing is compared to the real object. And then next is consider the level of detail. Scaling up may reveal a lack of detail that needs adjustment, while scaling down might cause the details to become congested or lost. Adjust the level of detail as appropriate for the choosing scale. So, adjust the details. When you make a drawing bigger, some parts might look empty or need more detail. When you make it smaller, some small details might look crowded or disappear. So add or remove details depending on the scale you use. So next is use reference points. When manually scaling, establish and mark cake measurement anchors or reference point. Example given, the corners of a room, a figure's height, to cross-check proportions regularly. Use reference points when scaling by hand. Choose important points like the corners or height to guide you. These points help you check if everything stays proportional. And then the last topic is practice and patience. Scaling effectively is a skill that requires practice, regularly cross-checking your work and avoiding the urge to rush will help prevent common errors. So, practice and don't rush. Scaling takes time to get right. Check your work often and avoid hurrying so you don't make simple mistakes. The more you practice, the better and more accurate you get. To sum up, scaling is important because it helps us create accurate, readable, and professional drawings. It makes big objects manageable, small objects detailed, and communication clearly among designers and builders. So, as the last reporter, I hope my explanation helps you understand why scaling is such an essential part of technical drawing. Thank you for listening.